Welcome to the ET380 Varactor Tuned Resonance Circuit Lab. Okay, here's a circuit we're going to build in multi-sim. And here is the Varactor that I replaced. It's a BB640. It's got a large range. And what's happening here is that this is a capacitive circuit in parallel here with a inductor circuit. And it's going to give us a tank circuit, a resonance circuit, and we're going to use it as a tuner based on our DC voltage on our bias. And this DC bias will change the capacitance of our Varactor and change that resonant frequency. Here I'm showing two Varactor circuits. So what we have here is a special diode, and based on the bias that we put on here, if we add voltage in reverse, our dielectric widens, which changes our capacitance. If we put a lower voltage on it, our dielectric narrows, also changing our capacitance. So essentially this is a variable capacitor based on our applied voltage in reverse. Okay, let's take a look at our diode capacitance chart based on our reverse voltage and our capacitance at the same time. And this one's got a large ratio, and that's why one of the reasons I chose it. And maybe we could see a big difference in our slab. Okay, here's our Varactor tuned resonance circuit that I built in multi-sim with our changed values. So let's go ahead and open our scope and our Agilent oscilloscope, and let's start our simulation. If we get an error, just ignore it and do not utilize the application. It'll just make things miserable. So I'm going to use 1 volt in. There we go, and ignore that. Make sure you push no, otherwise you'll get lost for quite a while. So we need to restart and let's go to frequency, and we're going to be around 50K, I believe. That's a good place to start. And these are pretty small. There we go. There we go. So what we're going to do is we're going to adjust our frequency until we maximize that circuit. And it is working good. So let's go ahead and increase our voltage there a little bit, and it's in this area here somewhere. And let's spread it out, and let's do a single sequence measure, and we're going to do peak to peak, back, and then let's go ahead and check our frequency, let it do the work for us. And we're going to have frequency there, and we have 42 kilohertz, which looks like the frequency at that point. Here I've taken a close-up of our oscilloscope at 0 volts, and we show that its resonant frequency is 42 kilohertz. Okay, let's go to the next voltage in our chart. Let's move these guys out of the way. And this guy should be 0.5 volts. Okay, let's restart this. Restart our scope. And start dialing in our frequency. I think it should be up. Alrighty. And we're at 46K. Let's see if we get anything else out of this. Looks like 46K. So let's lock in our scope. Okay, let's go to the next value on our chart, and that is 3 volts. Let's change our VCC here, restart it, restart our scope, and start cranking up on our frequency here. And that looks close enough for me. So let's do a run. Let's do a sequence, and we're at 62 kilohertz, which is looking reasonable. Okay, here's a close-up of our oscilloscope showing 62 kilohertz at 3 volts. Let's change the next voltage in our table, and it's 10 volts. All right, restart, and let's bring up our frequency until it starts to resonate. I went too far. All right there, I'm going to call that good enough. And we have 110 kilohertz. And let's lock it in and call that good. Here's a close-up of our oscilloscope screen. At 10 volts, we're getting 110 kilohertz. Let's go to the next voltage on our chart, and it's going to be 20. Start our simulation, move our scope over, get it running, and let's start bringing up our frequency. And yeah, I'm going to call that perfect. Let's spread this out a little bit. And let's lock it in with a single sequence. And I've got 180 kilohertz. Good. Okay, here's our oscilloscope close-up at 20 volts, and we have 180 kilohertz. Okay, so let's go to our last one, 30 volts. And being this is a virtual, I don't think we could blow it up, but let's go ahead and try again, and let's run it. And I'm going to call that good. 240. That sounds reasonable. Here's our close-up of our 30-volt circuit on our oscilloscope, and I showed 240 kilohertz.